Okay, so right now I'm going to go over a couple of problems from the classwork that was attached to your notes for day 6. It's asking you to write the equation of the inverse relation. So let's work with this relation. Y equals 3x plus 1. We'll call this our original relation. Now we're going to write the equation. So you guys remember that when we discovered the line y equals x was what everything reflected over, we also said we could take that literally and let y equal x and x equal y. So we're just going to do that. We're going to say x equals 3y plus 1, and then we're going to solve for y. Now I know this one is a little bit easy. It's just kind of like a warm-up. So I subtract 1, so I have x minus 1 equals 3y, divide both sides by 3, and then I have y equals x minus 1 over 3, x minus 1. Okay, so that would be my new inverse relation. This right here would be the equation of my inverse relation. So let's move on to something a little bit harder. I want you to take a look at number 11 on that page. It says y equals x squared plus 3. This is a little bit harder only because of our domain and range rules. Now, remember when we were talking about inverse, we said, so here real quick, this is my original relation. The domain, let's talk about what the domain and range would be. But the domain of my original relation, domain, becomes the range of my inverse relation. So for my inverse relation, it would be the range. So range, I just want to write this out. Okay, so what's the domain for our original relation? Well, it's a parabola, and it's just been shifted up 3 units. So I know that it's increasing, and it's going towards infinity as I look to the left of my graph, and as I move to the right of my graph on the x-axis, it's also going to infinity. So it looks like my domain is all the real numbers, negative infinity to infinity. Okay, so that means that that is the range of my inverse relation, negative infinity to infinity. Okay, inverse relation, original relation. Now let's talk about the range of my original relation. What would the range be of my original relation? Well, we know it's a parabola, and it's shifted up 3 units. So where is it defined on y? Well, it's defined at y equals 3, but it's also defined for everything above y equals 3. So that's why we say it's from 3 to infinity. And so then that becomes the domain of my inverse relation. I would say 3 to infinity would be the domain. Let's check to see if that's actually right, okay? Excuse me. So we have that this equation right here, y equals x squared plus 3, is our original relation. Let's solve for the inverse relation. I'm just going to rewrite it. Y equals x squared plus 3. Solving for our original relation. Solving for our inverse relation, I have to switch x and y. So I have x equals y squared plus 3. First step's done. Now let me solve for y. So I have x subtracting 3 on both sides equals y squared. Okay. Now, how do I get rid of something that's squared? I have to take the root, the corresponding root. So since this is being raised to the second power, it's y squared, I have to take the square root of both sides. Okay? When I take the square root of something, it is always plus or minus. I have the positive version and I have the negative version, because you know if you square something positive, you get something positive. But also if you square something negative, you get something positive. So my answer would then be y equals, because the square root undoes the square, plus or minus the square root of x minus 3. Okay, so let's talk about what would the domain and range be for this graph, and let's see if it's the same thing as what we predicted it would be before. Well, let me think about what my square root function looks like, okay? My square root function is a gradually increasing function, but since I have this minus 3 over here, it means I'm moving 3 to the right. I move my starting point 3 to the right. It's normally at 0, 0, but it will move 3 to the right. So my square root function is going to look something like that. That's only the positive half, okay? The positive half. We know the negative half right there is actually this graph's reflection. So the negative half is something like that. Because I had to do plus or minus. So this was the plus part, this was the plus part, and this part was the minus part, okay? And that makes sense because the original relation, which was right here, is a parabola. So my inverse relation looks like a parabola too. So let's check to see what is the domain and range. Okay, the range, well, that looks like, where is it being defined for y? Well, it's gradually going to be decreasing as I approach infinity on my x. And here it will gradually be increasing as x approaches infinity. So it looks like it would be all real numbers. Negative infinity to infinity. Now what about my domain? Okay, it's not even starting on the x-axis until here, this point, until x equals 3. So it includes 3, it's defined on 3, but it goes all the way out to infinity. So that's my domain. Now let's check what we found up there. We said our range should be negative infinity to infinity, and our domain should be 3 to infinity. And it looks like that is what we got. So that's how we know that we did it right. Alright, just so you guys know, this was the graph and the function. Well, this is the function for my inverse relation right here, okay? And this guy over here is the graph for the inverse relation.